Hi, welcome to Algebra 2 Common Core. Today in lesson number 10, we're going to review the process of completing the square to solve quadratic equations. You covered this method completely in Algebra 1 and then you reviewed it somewhat in geometry, but we're going to need it a lot in Algebra 2, so we're going to practice some more today. So the questions will start something like algebraically find the roots of the equation, and they will specifically tell you to use the method of completing the square. This is just one method that we can use to solve quadratic equations. You'll remember a few lessons ago we used the method of factoring and setting the factors equal to 0 to solve quadratic equations that were factorable. This method can be used on all quadratics, whether they are factorable or not factorable. So I've written down the steps, so as we go through the process, make sure that you write the steps in your notes as well. So our first example, y equals x squared plus 2x minus 1, we want to find the roots. So if I'm looking for the roots, that means that I want to take that equation and set it equal to 0. So I'm going to rewrite this as x squared plus 2x minus 1 equals 0. Now our goal in the method of completing the square is to get my left side of the equation to be a trinomial that is a perfect square trinomial. A trinomial that can be factored into the product of two identical binomials. So in order to do that, I'm going to have to take the constant and move it over to the right side of the equation. So I'm going to have now x squared plus 2x, and I'm going to add 1 to both sides of the equation and get a 1 on the right side. You'll notice that I've left some room because we're going to be adding on a constant here. And whatever constant we add to the left, we're also going to have to add to the right. So we'll figure out what that constant has to be. Now, usually we're going to have to take a look at our quadratic equation and say, does our a equal 1? In this case, the coefficient of x squared is 1, so I don't need to do step number 2. So let's move to step number 3, where we're doing the process of completing the square. So for this process, we are going to look at our b, which is our coefficient of the x term. In this case, it's 2. We want to take half of the value of b. So I'm going to multiply 1/2 times that coefficient of x, and then I'm going to square that number. Half of 2 is, of course, 1, so 1 squared is just 1. So I'm going to take that number and I'm going to add that to the left side of the equation and also to the right side of the equation. What that does is then give me a trinomial that is a perfect square trinomial on the left side. So that is definitely going to be factorable if I have done this process correctly. So when I look at this trinomial, I say x squared plus 2x plus 1 is going to be factored into x plus 1 times x plus 1. On the right side of the equation, I add together the 1 plus 1 and get a 2. But of course, I can rewrite this as x plus 1 squared is equal to 2. So my last step is to solve for x. So to solve for x, I'm going to have to take the square root of both sides of the equation. So I will get x plus 1 is equal to the positive and negative square root of 2. So to finish this off, I'm going to get the x by itself. So let's go ahead and do that by subtracting 1 from both sides of the equation. So I get as my answer x is equal to -1 plus or minus radical 2. Now usually we're going to want to leave our answer in that radical form. You'll notice that that tells me that the roots of my equation are irrational because I'm ending up with a square root as part of my answer. And it's the square root of a number that is not a perfect square. So that tells me that my roots, my two answers, are irrational. Now, sometimes it's going to be necessary for us to go to our graphing calculator and calculate what square root of 2 is, and then take -1 and add that number, and then subtract that number to get our two solutions. So really what we have come up with here are our two solutions. X is equal to -1 plus radical 2, and x is equal to -1 minus radical 2. So for this example, I'm going to leave my answer in radical form. Let's find the roots of exercise number 2, y equals x squared plus 8x plus 14, also by completing the square. So first of all, we're going to take our x squared plus 8x plus 14 and set it equal to 0. Next step, we want to move that constant over to the other side of the equation. And while we're doing that, we want to leave a space because we know that we're going to have to add a constant to both sides of the equation. So to figure out what the constant is, I'm going to take the b term, and I'm going to take half of that b term and then square it. So half of 8 is 4. 4 squared is 16. So I'm going to add 16 here and also here. Now you'll notice that when I do that process of completing the square, I'm always going to be adding a positive to both sides of the equation. So when I look at x squared plus 8x plus 16, I know that that factors into x plus 4 times x plus 4. On the right side, combine your constants, and I have a 2. So of course, this can be rewritten as x plus 4 squared equals 2. And my last step is to solve for x, so I'm going to take the square root on both sides of the equation. Now when I square root a binomial that's squared, it just gets rid of the squaring. So x plus 4 is equal to, on the right side, I also have to take the square root, but remember to take both the positive and negative square root. Finish the solution by subtracting 4 from both sides of the equation. We're always going to write that before that radical. So I have as my two solutions -4 plus radical 2 and -4 minus radical 2. So again, depending on the context of the problem, if it's a real-world application especially, I'll want to pull out my graphing calculator and get a decimal approximation for these two answers. Again, I see that radical 2 is an irrational number, so that tells me that I ended up with 2 irrational roots. For exercise number 3, it specifically says I want to find the exact values of the zeros. That, of course, tells me that I don't want a decimal approximation. I'm still looking for the roots or the intercepts, so I'm going to take my function -x squared minus 4x plus 2 and set it equal to 0. It says to follow the method of completing the square. So my next step is to move the 2 over to the other side of the equation, leaving room for a constant to be added to both the left and the right side. Now here's one where I do have to take that extra step. I've got a coefficient in front of the x squared that's not a 1. So I'm going to want to go through and divide both sides of the equation, every term by whatever that coefficient is. And in this case, I'm going to divide by -1. So I now have x squared plus 4x plus something is equal to 2. And again, I'm going to add that same plus something to both sides of the equation. So off to the side, I'll say, okay, let's take our b term, 4, and let's take half of it and then square it. That's going to tell me what is the constant that I'm going to add to both sides of the equation. This is really the process of completing the square. Half of 4 is 2, 2 squared is 4, So I'm going to add 4 here and also here. So the left side, that trinomial, can be factored into x plus 2 times x plus 2. On the right side, I've got the answer of 6. So this gives me an x plus 2 squared is equal to 6. So to solve for x, we're going to take the square root on both sides. So we get x plus 2 is equal to the positive and negative square root of 6. And then get the x by itself. So x is equal to negative 2 plus or minus radical 6. Now again, because the question said give the exact values, I am definitely stopping here and not putting a decimal approximation. If I had to write the two solutions separately, I'd say negative 2 plus radical 6 and negative 2 minus radical 6. And again, because 6 is not a perfect square, both of these answers are irrational roots. Moving on to example number 4, we want to find the roots of 2x squared minus x minus 1. So let's set that polynomial equal to 0 because that's going to, of course, allow us to find the roots. Move the 1 over to the right side of the equation, so 2x squared minus x equals 1. Now in this case, I definitely have to go through and divide each and every term by the coefficient of x squared. So I'm going to divide by a 2. So I now have x squared. I'm going to think of this as minus 1/2 times x. And again, I've got to add something to that side to complete the square. On the right side, I've got 1/2. So let's go off to the side, and my b term is negative 1/2. I need to take half of that b term and then square it. So that's the same as saying 1/4, negative 1/4 squared. Now it's a lot easier to solve these problems if you leave this in fraction form versus converting it over to a decimal on your calculator. So when I square this, this is giving me 1 over 16. So that tells me that I need to add 1/16 on the left side and also on the right side. Now a good thing to remember here is when I'm doing my factoring on the left side, I'm always going to have to factor into x. I'm going to keep this sign, so it's going to be a minus. And then whatever my half number was, in this case the half number was negative 1/4, that's the number that goes inside of my factor. So it's going to be x minus 1/4 squared. Now on the right side we need to add together 1/2 and 1/16. So that's the same thing as saying 8/16 plus 1/16, which gives us an answer of 9/16. Now if you need to, take a few minutes to think about where we got the left side and the right side of the equation. And again, remember that this number right here inside my factor is always going to be whatever half of the b was. So it's the number negative 1/4 in this case before I do the squaring to figure out what to add to both sides. This negative 1/4 goes right here. So now I'm going to go ahead and solve for x. So I'm going to say take the square root on both sides of the equation. So this is going to be the positive and negative square root of 9/16. Now it happened very nicely for us because I got a number that happens to be a perfect square. So I'm going to add 1/4 to both sides of the equation. And when I do that, that's going to be 1/4 plus or minus, the square root of 9 is 3, the square root of 16 is 4. So I have the two solutions, 1/4 plus 3/4. When I add those together, that's giving me an answer of 1. And then my second solution, 1/4 minus 3/4. That's giving me negative 2/4, which is negative 1/2. Now when you look at those answers, 1 and negative 1/2, both of those answers are rational roots. I don't have any radicals. I can rewrite these as a decimal that doesn't repeat, or I'm sorry, that doesn't keep going on and on and on. So take a few minutes and make sure you see where all the pieces of that solution came from. Let's try exercise number 5. Find the roots of the equation y equals x squared plus 6x minus 11 by completing the square, but then verify it on your graphing calculator. So take your quadratic, x squared plus 6x minus 11, set it equal to 0 because again I'm looking for the roots. So that means the y must be 0. Now add the 11 over to the other side of the equation. So I now have this form. I want to figure out what I have to add on to both sides of the equation. So I go off to the side and say my b value is 6. I want to take half of 6 and then square it. So half of 6 is 3. 3 squared is 9. Let's add 9 to both sides of the equation. So on the left side, this can be factored into x plus, remember it's always going to be my half number. Half of 6 is 3, so that's the number that goes inside my factor. So it would have been x plus 3 times x plus 3, or of course I can write it as x plus 3 squared. On the right side, adding those two numbers together, I'm getting an answer of 20. Now let's solve for x. So I've got x plus 3 is equal to the positive and negative square root of 20. And then move the 3 over, so x is equal to negative 3 plus or minus the square root of 20. Now for this one, because it says that I'm going to take a look at these solutions on my graphing calculator, I want to go ahead and put these onto my calculator so that I get a decimal equivalent. So basically I am just going to type into my calculator 3 plus the square root of 20. And when I do that, negative 3. I forgot the negative there. Negative 3 plus the square root of 20. And when I do that, I got the solution rounded. It's 1.47. Now let's do negative 3 minus the square root of 20. And when I did that on my calculator, I got negative 7.47. And again, that's a rounded solution. Now what that means is that when I go to my graphing calculator and I graph this function, I'm ending up with my roots at negative 7.47. So that's going to be right about here. And 1.47, which is going to be right around here. So look at your calculator. This is going to be a parabola that opens up like a cup, so you should be able to take a look at that parabola on your calculator, and it should cross your x-axis at those two roots. And again, these are irrational roots, so I won't see exactly on my calculator where the graph is crossing the x-axis, but I will be able to see that it's between, on the negative side, between negative 7 and negative 8, and on the positive side between 1 and 2. Now I've got some you-try-its for you to practice, so I'm going to have you write these you-try-its down, do them, and then come back and check your work with mine. Please write down these two you-try-its underneath the practice on page 18 of your notes. Go ahead and solve for the roots, and let's leave them, if they are irrational answers, leave them in radical form. When you're done, come back and check your answers with my work. Hi, welcome back. Please check your answers for completing the square for these two quadratic equations. For number 1, I got my final answers were x is equal to -3 plus or minus the square root of 5. You'll notice that I moved the -4 over to the right side of the equation. I completed the square by taking half of 6, which is 3. 3 squared gives me 9, so I added 9 to both sides of the equation. That allows me to factor x squared plus 6x plus 9 into x plus 3 times x plus 3, which is of course x plus 3 squared. Now I'm going to take the square root on both sides of the equation. On the side with the number, make sure you do the positive and negative square root, and then subtract 3 from both sides of the equation to get the solution. For number 2, I did the same thing by setting the equation equal to 0 and then adding 21 over to the right side of the equation. Because the x squared had a coefficient other than 1, I divided each and every term by 3. So that gave me x squared minus 4x equals 7. Completing the square, I take half of -4, which is -2. -2 squared is +4, so add that to both sides of the equation. Again, that gives me a hint as to what my factors are going to be. Because my half number was -2, my factor is going to be x minus 2 squared. Take the square root on both sides, add 2 to the right, and I get the irrational roots x is equal to 2 plus or minus square root of 11. Thanks very much. Hopefully you're getting some good practice on completing the square, because we're going to be needing this for the rest of our unit. We'll practice some more of these in class. Have a great night, and we'll see you tomorrow.